Whether this is I or E, monotonicity, I or E, this variable. I, good, thanks. Okay. Just like when we talk about the extreme value, if value is a maximum value or minimum value, then we call this number is an extreme value. If we say some number f of c is a relative extreme value, means this number is a relative maximum value or relative minimum value. Same. If a function is increasing or decreasing on some interval, then we say this function is monotonic or monotonic on this interval. Monotonic. Maybe increasing or maybe decreasing, cannot up and down. Either goes higher than higher or lower than lower. This is called monotonic.跟以前讲到的极值一样，我们把极大值跟极小值叫做极值，把相对极大、相对极小叫做相对极值。一样的，一个函数在一个区间是递增或递减，就把它叫做单调函数。一个函数在某个区间是单调的，表示这个函数在该区间要么是单调递增，要么是单调递减。所以单调递增跟单调递减合称，递增跟递减合称单调型。极大跟极小合称为极值啊，极大值跟极小值合称为极值。So increasing decrease test. Sometimes we say this test is monotonicity test. The condition is very very mild. Suppose I is an interval. F is continuous on an interval I, and F is differentiable on the interior So again, when we talk about the continuity, sometimes containing the endpoint, because at the endpoint we only consider continuity from one side. But when we talk about derivative, we always consider two-sided limit. So differential on the interior of I, for example, not on this terminal endpoint, maybe inside. Okay. So I not necessarily a finite or bounded interval, maybe infinite, maybe open, maybe closed, maybe finite, maybe infinite. Okay. The conclusion is, if f prime of x is always positive for all x inferior to I, because at the endpoint, the differentiability are not we don't talk about the differentiability at the point, because when we talk about derivative, always two-sided limit. Then this function will be increasing on the whole interval line. Okay, intuitively, if at some time a, the position of this function of some particle whose position is f of a and the velocity always positive means moves up, never back. So the curve of this function will be higher and higher and higher. Statement 1. Statement 2. Okay. Continuous on this interval and differentiable interior to this interval, and the derivative always negative. So at time a particle whose position is f of a, but the velocity always negative means move to the right, left, or on this axis always move down. Okay, move down. Therefore, this function is decreasing on this interval. Number 3. In fact, number 3 is the last theorem of the previous section. I put the result here more suitable. If some interval a b, some interval I. If the function is continuous on this interval and differentiable in this open interval, interior to this interval, and whose derivative always 0, then means the velocity is 0. So this particle must be rest at some position. Okay, rest. Okay? No. The graph is a constant, but the value is a constant. The graph of this function is a horizontal line. Okay. But the particle I mean, if you have a clock, some position C, means this particle rests here. Never moving, because the velocity is zero, always zero. So the graph of this function is a horizontal line or a part of a horizontal line on this interval. But the value is only one number. So this function is a constant on this interval line. Okay, all this results can be read from mean value theorem. Why? Let x1 and x2 be any 2 points or 2 numbers, even one of them is an endpoint. For example, let x1 be 2 numbers in that interval I. For example, x1 is the left end point, x2 is the right and interior point. By the conditions, by condition 1, f is okay, because if it happens that one of them is an endpoint by the continuity of a function on an interval, when one of them is an endpoint on here, means this function is continuous from the right at a or at x1. If x2 is an endpoint, by the continuity of this function on the interval I, B is an endpoint of this interval. So f is continuous from the left at B. Okay? So this condition automatically satisfies. Aha. The interior of this one is certainly contains in the interior of the original one. Right? Because open interval does not contain the endpoints. Right? 所以真的呢，任意给2个点，哪怕其中一个端点都没有关系。反正讲到连续性都是讲到单边，在端点的话是单边连续。可是讲到可为都是内部，这个内部当然是不包含端点，就会在原先这个内部都满足。So these 2 conditions are exactly the conditions of the mean value theorem. Therefore, by the mean value theorem, we have this equality. Suppose in 1, f prime of x is greater than 0 for all x interior to I. Since C between x1 and x2, and x1 and x2 is contained in this interval I. So C is also an interior point of that interval line. Therefore, f prime C is positive. All members have this property. But one of them, any one of them must have this property too. Okay. So f prime C is greater than 0. Now, x1 is less than x2. x1 is less than x2. So this number is positive. This is also positive. Positive times a positive is positive. So this is small. F of x1 is smaller than f of x2. So we have proved. In 1, if x1 is less than x2, then f of x1 is less than f of x2. So f is increasing amount. Preserves the order. OK， 所以说用均值定理就可以知道，如果 x1 比 x 小，这比这个小，减一减小一点，这是正数嘛？所以这个减一减也要是这个也要比这个小。正数乘正负，这个还是正数，出来是正，符号没有相反，代表 f(x1) 比 f(x2) 小，所以 x1 比 x2 小 ，f(x1) 比 f(x2) 小，代表这。